čudno, jer ja se trebam da pričam i da...
Znam.
Se čuje? Jeste. Zdravo svima. Ja se nadam da me čujete. Ako me čujete, klimnite glavom ili nešto radite. Ok.
Ima dugme pozadi.
Ja sam Igor, dolazim iz Hip Space-a, jel te, i vodit ću ovu ovde salu ceo dan. Počinjemo danas sa predavanjima. U svakom slučaju, pitanja u vezi predavanja uvek možete da postavljate na ovom botu ovde, na linku koji vidite, potražite. I ako imate neko pitanje... I have to speak in English, sorry. So, if you have some question, just find this bot and ask whatever you want. After the talk, I'm going to read the most interesting questions according to time that we have. All other questions, of course, you can ask after the talk. So we are going to start with Vladimir. He's coming from Amsterdam Java user group, and he will talk about APIs and microservices, his experience. Enjoy.
Okay, welcome to my talk, changing wheels and moving cars from monolith to microservices by using APIs. Everybody hear me, right? Okay, cool. Okay, so first of all, let me introduce myself. My name is Vladimir Dejanović, and I'm the founder and leader of Amsterdam Java user group. And my day job is chapter lead in ING. ING is a front runner in IT when it comes to banks, and the idea is that we want to become the front runner in IT in general. I'm very happy to be here on this conference and in Belgrade, and one of the reasons that I'm very happy for it is because although I'm the founder and leader of Amsterdam Java user group, originally I'm not from Netherlands. Actually, I moved there in 2014 from my hometown, Belgrade. So I'm very happy to be here. So, what is talk going to be about then, right? If you put the title of a talk in the Google, you'll end up with something like this. So, yeah, you can change wheels on a car while it's moving, not that I recommend you to do it. This talk is going to be about doing this, but from IT perspective. So, making change in live systems with no downtime. And sometimes even without, like your boss knowing. So, doing the tough job in fast way and keeping the job. First of all, I will spend some time on important truths and questions that we need to ask ourselves before we go on this dangerous road. After that, I will spend some time in breaking a monolith, some good practices and bad practices, and then I will be talking about the APIs and why we should use them more. At the end, there will be some time for questions, at least I hope, because some of you might notice V3 in the title of the talk, and that is because this is the third version of the talk that I'm trying to give, and every time I'm run out of the time, because there are a lot of things that I want to tell, so I try always to make it compact, so I'll try to be fast and leave some time for questions. Again, at any time, if you can talk to me after the conference or catch me online, go for it. So let's first start with a war story, but of course IT war story. Again, because of the lack of time, I will not go into all the gritty details. So again, if you want more info, just come to me and talk to me later. So I was a new face on a project, and this project was responsible for collecting money from multiple third-party systems, according to some very complex business rules, and also sending money to a lot of third-party systems, again, to very complex business rules. So not very important part of the system, right? Only all the money that went inside the company or went outside the company was touched by it in some way. And there was a small issue basically in the system. Basically, one other team did some development, but they didn't really fully understand the business rules, so they introduced small bug. They corrupted the small part of data. And when I say small part of data, it's relative, because if we didn't fix the issue, the company would lose about 10,000 euros. So again, depending on your profit margin and your point of view, maybe it's not that small, right? A colleague who works on this project for a long period of time came to me, and he was very experienced on this project, because again, I was new. He said, oh, no worries, I know exactly what the problem is. By the way, I created this script, it's going to solve all of our problems. Oh yeah, I'm off for vacation, so you run it. So I did what every person would do, right? again, like I was a new face on the project, so I had no clue about it. And again, this guy was here for years, so I assumed that he knew what he was talking about. I assumed that his script is good, that he covered all the edge cases and everything, so I pressed the button, right? How many of you think everything went according to the plan? Yeah, you're right. Well, it didn't really go according to the plan. You know, one might say that even it went completely opposite from what intended thing was, because not only that it didn't solve the problem, it made the problem even bigger and much worse. And the scale on which the issue became bigger is, if I go back, issue was 10,000 euros, right? 10,000 euros. It grew to 1.3 million. One might say not a really good start in a new project, right? It took us months to fix all the issues. At least we hope that we solved all the issues. Product owner from that time still has the nightmares, I assume, because he still is not 100% confident that we fixed all of them, because this issue came back to us over and over again in multiple times over a longer period of years. So, not years, but longer period of time. So, but yeah. Again, not all was bad, you know. Again, if you make a mistake, it's not a big deal as long as you learn something from it. Making the same mistakes over and over again, that's a big problem. And this incident, if I can call it this way, gave us more than enough, things to learn from. At least I know that I learned a lot from it, and I made a lot of changes in the way that I do stuff, and basically improve myself. So, what are the lessons learned? Lesson number one. If you go back basically to what happened and you just think about it, it's very obvious why the problem occurred, right? Because I assumed that my colleague knew what he was talking about. I assumed that he covered all the edge cases. I assumed that his script was good. And none of that was correct. So, of course, the lesson number one is don't assume things. Assumption is the mother of all fuck-ups, like stated here. And this was proven to me on more than one occasion. So that's why after this basically became like my first rule, never assume things, always know things. Because whenever you assume things, that it means that something you don't know and it might go wrong, And again, if you can't know things, then be ready to accept the risk of not knowing. Lesson number two. Again, I looked into this incident and basically why it grew so fast and why it was like from 10,000 to 1.3 million. And again, result is very obvious when you think, basically when you put it in the retrospective. So original problem was in small part of corrupt data, but that part of data was only in our system, isolated from everything else. And we knew that it's bad, so we didn't touch it. But once I run the script, we thought, okay, all is good. So we let it go throughout the whole our system, and also we sent it to other systems. And this was a big mistake. Basically, we had a small fire, which we left to become like a wildfire. So, lesson learned, whenever you're dealing with the data, be extra careful. Especially if you collect the data, basically consume data from the third-party systems and also send data to the third-party systems. You don't want for corrupt data to expand to other systems and corrupt other people's products, because then it's even worse. Lesson number three. I didn't mention to you how much time spent was basically between me running the script and us finding out that there was a problem, right? Well, I'm ashamed to say, but it took us over a week. And in the end, we didn't even notice it. Our consumers came to us and said, oh, no, you know what? The numbers are funny, they don't add up. And I can tell you for sure, this isn't the place where you want to be. Again, if you put it into retrospective, why this happened, answer is obvious. Lack of monitoring. You have to monitor everything. You need to know everything what is happening in your application all the time, preferably in real time. Because if you know what's happening in your system, and if something went bad, then you can react to it, you can solve it, You don't want for your users to come to you and say, you know what, this doesn't work, there's a bug there, Trust me. Basically, if you don't have a good monitoring, you're doing this. You're going full speed through the fog, and you can say, yeah, but so far everything was good, right? We didn't have any problems. Well, my answer to that would be, just look at us. This is accident waiting to happen. At one point, it's going to hurt you. Only the question is how bad it's going to be. And you will be hurt in reputation and the money. We live in the fast-paced world, of constant change. The systems of today are not the systems of tomorrow. Users of today are not users of tomorrow. Users constantly request richer user interfaces, basically more user experience, faster response times and everything. And basically, systems of today will not be good enough for world of tomorrow. So because of that, we also constantly need to push our systems to change them, to make them better, to respond better, to give more features. IT is like a shark. If you don't move, you will die. And of course, constant change that we have to do doesn't come without its risks. And the biggest risk of them all is, of course, the systems will break. Just imagine having a system which was serving millions and millions of users, and all of a sudden it stopped working. Or even worse, start sending randomly bad data, So what should we do? But let us wait for a second. Let's step back and let's look at some questions basically that are going to help us answer this problem, Oh yeah. First of all, we need to basically accept that the real question isn't if the system will break. The real question is when the system will break. Only systems which don't run will not break. Every system will break at one point of a time. It is the fact of life. Hard drive can die on us, network cables can die on us, data centers can lose power, users can change the way they interact with your application or how much they interact with your application. What's going to happen with your code if it's not built for scaling to 1 million users, and then you're hit by 1 million users, What's going to happen with a leap year? Are you sure your system will handle the leap year in correct manner, or even the end of year for that matter? What's going to happen when user goes from one time zone to another time zone? Will your system still work as intended? Only once we accept this imminent doom and that things will go wrong, only then, and then we can basically start doing stuff and basically making it better. Accepting is always the first step. In a nutshell, you don't want for one small fault in your system to do this, bring everything to a halt. Errors will happen, things will break, and basically if this can happen to your system, after only one small issue, then you should fix that small issue right away. So you might ask yourself, okay, but if we accept the fact that systems will break, that things will go wrong, how to make sure that our users are not aware of it? How to make sure that that we mitigate the problem and that users don't see the problem? And again, you need to remember, as long as the users don't see that you have a problem in your system, everything is good. And again, if you can't hide the fact from them that something is broken, downgrade user experience gracefully. So don't just break everything, just find a way to show them something else. So, now we come to important questions that you need to ask yourself and always keep it back of your mind. By asking these questions, you will be able to basically know what you need to do and how to make your systems more robust and more resilient. Question number 1. First thing that you need to ask yourself is, will you know if something is broken or not? How fast will you find out that something is broken? How will you find out if something is broken? It might sound silly, right? But if you go back to my example, we didn't know that system was broken for over a week. And in the end, we didn't even find out ourselves, but the customers came to us and said, okay, the numbers don't match. And this isn't the place where you want to be if you're dealing with somebody else's money, believe me. You need to know right away that something is broken, because if you know that something is broken, then you can react to it. You can make the changes to the code. You can actually somehow gracefully downgrade user experience so that they are not aware of it. If you don't know that something is broken, you will not react. Question number 2. Will you be able to fix it? And how fast will you be able to fix the problem? Again, it might sound as a silly question. In the end, you build the system, you own the system, so you should be able to fix it, right? But think just for a second, systems of today are more and more complex. There are more and more moving parts, And again, a lot of things can go wrong. Like I said, network cable can go down, hard drive can go down, database can be corrupted. Do you have access to all of the systems? Can you fix all of them? Do you have root access on the database? Do you have access to the networking or not? Or you need somebody else's help? Again, how much time you need to solve certain problem? Do you need minutes or you need days? What you're going to do in between? Question number 3 is tightly coupled with the first 2 questions. And it basically goes, what will be the impact if something goes wrong? Will your end users going to be a little bit annoyed? Or this? Again, this is very important, especially if you're changing live system in production, and even more important if you're going to change something, without your boss knowing. And again, like by answering all these three questions, you're going to do different things depending on the different parts of the system. And you should ask these 3 questions for every part of your system and your system as a whole. And again, depending on the answers, you will do different stuff. And if your answer to any of them is, I don't know, then I suggest find out right away, because you might be going to this one and not being even aware of it. Okay, so now that we know all the important stuff, how are we actually going to break the monolith, And even more important question, should we even do it in the first place? The funny thing is that although there is a lot of talks and articles about it, there isn't one universal answer, because it really depends from your use case to the use case. And if you go back to the question, should you even go to the microservices? My answer would be, again, depends, but if I would have to choose between bad monolith or bad microservice, I would choose bad monolith. The only constant thing in this philosophical question is that when you have a monolith, basically you have one system which does something, and when you have microservices, you have a lot of systems which in theory do exactly the same thing. Of course, the big difference here is that what in monolith used to be internal function calls and method calls are now network calls. I will not go into all the details, good and bad, what this brings us and how this affects us, because it's a talk in itself. But the important thing that you need to remember is that you don't have to come back, basically, when you break the monolith, to this complete state, and having like millions and millions of microservices. And you might think, okay, but that sounds strange, because in 99% of the cases, when somebody talks about microservices, or have a talk about microservices, or article about microservices, they show something like this. Lots and lots of small, nice cubes. Because again, microservices are nice and cool, right? And small. Well, you don't have to go all this way in most of the cases, and in some cases there's even very good reason why you shouldn't be going this whole way, like into this granularity. But let's take a look at basically at some of the ways that we can basically break the monolith. So one way which is done very often in talks and discussions is basically splitting our application horizontally. No, vertically. Yeah, I always mix this up. And this is a very good way that basically you can split your application if it's logically can be split. And again, in this way you can handle the load from the users and everything in a very simple way. Again, like, for example, let's take Amazon.com, for example. If you think about the system, you have a part where basically you as a user go and search for some stuff. And then you also have a part of the system where you actually buy stuff. Those 2 systems can be logically split. Because again, use cases of the users differ for them. On one case you have a high load, on another you don't have that much of high load. Also, if something goes wrong, in one case you will be annoyed, or maybe you won't even notice. Like if search doesn't return all the results, you will never know. On other parts of the system, if you're in the middle of the payment and you're buying a new laptop, which is very expensive, and something goes wrong, you will be more than annoyed. So that's why the answers to those 3 questions differ per systems, and that's why you should handle them in a different way. Other way that you can be tempted to basically split your monolith is vertically, and this is very often tempting, especially if you had already very good layering option in your monolith. Some people will scream across the room and say, never do this. My answer to this would be, depends. This might be a terrible idea, this might be a good idea. It really depends what your use case is. This can be a very good idea in this case, where you actually have multiple systems that are separate and you want to keep them as separate. But again, you don't want to expose all of them over the internet, because again, internet is slower. You can have one layer, basically one application that your users are going to hit from outside the world, and then you keep all other traffic inside your network, which is very fast. And some big companies actually do this because they saw that this is how they get the best performance and best user experience. Basically, they handle everything internally and then just send one response back to the end users. Important thing that you need to remember is whenever you actually add microservices, you're adding network calls. Network calls means latency and delay. More network calls, more latency, and more delay, even before any of your business logic and code kicks in. And you need to take this into account. How is this going to affect your end users and their basically how they see your application, you know? Don't do the split just for split's sake. For example, if we take Opera browser, what they did in the past is when you request basically some page, actually they wouldn't go to the page, but they would go to their proxy server, their big machine, which would then collect all the things for that page, including JavaScript files, images, and everything, pack it into one zip, and then send back to the user. And that's why Opera had a huge margin, basically like part of the market in developing countries. I'm not sure if that's still the case, but basically it really helped them a lot when there's slow traffic involved. And of course, whenever you split a monolith, there's $1 million question, and what should we do with the database? Well, for this, I will not spend a lot of time on this because this is talk in itself, so you can join me in Romania while I give this talk. But I'll tell you just some important things. First of all, try and make sure the database is as stupid as possible. Move all complexity to your application. The reason for that is very simple. To spin up basically new application and to basically scale your application, it's like that simple. You need minutes. To scale up databases, you probably usually need days in most cases. Another thing that's very good is always try to keep whole database in memory. So whatever your server database holds, have memory there how big your database is. If your database is too big, then you need to split it up. And if you split database, then it means you can't really use triggers. Also, constraint on foreign keys is something that you should avoid. You should just remove it from the database and just leave it in the application where it should be. In this case, you're going to get much faster response time. Again, you might get some bad data in the database. So again, think, is that really the use case that you want to do everywhere? Another very important thing is, think very hard what type of data you need in real time and which you can use the stale data. For stale data, just denormalize it and have some scheduler or cron job which actually populates it from some time to time. Again, you're going to get much better performance. Okay, so APIs. I need to really pick up the speed. So, how can APIs help us? Well, I must admit that I really like APIs a lot, and I was developing the software in the quasi-API way even before I was aware of it. And the reason why I love APIs so much is because they're very powerful, they're very robust, they are adding a lot of robustness and basically future-proofing of your application without taking anything away. And this can be seen best from this picture here. Here we have an API who's basically producing the data, and we have all kinds of different consumers. In this case, basically, like, we don't care who's going to consume our data and how they're going to display it or use it. We don't care about it. API cares only about getting the request in, data goes in, and then basically sending the request out, basically response out, send the data out, and that's it. And you can also call from one API other API, and then you can even decide, okay, like this API I want to keep internal, so I'm going to keep it inside my internal fast network behind the firewall, or I want to actually expose this API for the whole world. Like, there are endless possibilities. You can do whatever you want. You know, there is no boundary for anything. And extremely good thing about APIs is they have natural fit in the microservice world, but also they have very good fit into old monolith world. So they can be used everywhere. And that's also one of the reasons why new APIs are popping up like mushrooms all over the time. Oops, my bad. So how actually we split the monolith, right? So first of all, you have a monolith and you want to split it into microservices, and you can go like full guns blazing, like let's create the millions of microservices. No, don't do that. Small step at a time. First, identify one part of a system that you would like to basically logically split from the rest of the system, and then start reorganizing your internal code and think about, okay, which parts of the system should be publicly available, basically public entry points in this blue box, and everything else should be hidden from the users. Once you're happy with how this looks like and you think, okay, I've done a good job, then you take it out. And at this point, you will find out if actually you did the good job or not, because it might break. Again, what used to be public entry points over the methods or the functions are now basically API endpoints. And when you do this, then you can think about the next steps. Okay, do I want to create a new microservice? Do I want to basically take this blue box and split it more? Do I want to reorganize internal code inside the blue box? You can do whatever you want to do. And if we go back to those three questions that you ask yourself, and you realize, okay, like this blue box is very, very important for my business. It's a core business. If this doesn't work, I'm doomed. Then I would suggest leave the blue box outside and inside your application at first. Do the network call. If the network call fails for any reason, do internal call and log that you had the problem. And after some time, when you see, okay, like everything is going good, all the time basically the network calls are giving me the response that I want, then you can just remove the internal block. And also, like I said, you can also take this blue box and basically expose to the whole world if you want. You can just add additional instances of it. Whatever you want to do, you can do it. Important thing that you need to remember is that although this is, like I call it now, blue box, for end users, it's a black box. They don't care what's inside it. Only thing that they care is, okay, I send this data in, my request, and they get this data out, response. So they have public endpoints that basically they interact with your application, and they shouldn't be changed. So if you add some things here, you create some endpoints, they need to be consistent. They need to stay there in the next version. You can't just take out some endpoint because you don't like it how it looks like. Because in the end, that's what your users see. So don't make breaking changes. When you make these publicly available endpoints, try to keep them forever. Forever is, of course, a very long period of time, so you can, after some time, find out that actually you need to make a breaking change. In that case, think about the strategy, how you're going to do it, how you're going to let your consumers know that basically they need to upgrade to the new version. How are they going to do the upgrade themselves? Help them along the way. Don't just say, okay, like, yeah, guys, from tomorrow, this endpoint doesn't exist. Okay, so let us look at some of the common mistakes that people usually do when they're breaking a monolith. Mistake number one that I see over and over and over again is that people say it has to be perfect. It has to be perfect. It has to be perfect from the start. As a result of that, you end up in a long meetings, endless meetings where a lot is going to be said. And again, from my personal experience, why people behave in this way is because they feel that once something is put out, it will be there forever. It will be written in the stone. There will be no way to change it, And again, everybody wants to show how smart they are, so they want to make sure that their project isn't as crappy as all other products built inside the company, right? Because we want to show that we know the best. What I always say in this situation is, sorry, but perfect doesn't exist. Something can be perfect only in your mind, As soon as something go outside your mind, and basically in the real world, you're going to find out about all the issues and bugs and problems that these systems have. It might not be tomorrow, but at one point in the future, it's going to happen. So that's why better build something now and put it to the end users. So build something fast, put to end users, and see how they react. See if all is good or not. Real story. I know a team who spent 6 months on gathering all the requirements and making sure that everything is perfect. And then 1 month after they basically didn't do any coding, then basically they did the coding, put production live. Less than a month after they put their API in production, they had to do version 2 with the breaking changes because version 1 was not good. Not even 2 months after that one, they had to do version 3, again breaking changes because version 2 wasn't good. So they ended up supporting version 1, version 2, and version 3 for the long period of time just because they were like, yeah, we need to make it perfect. Common mistake number 2 is doing it yourself. Our use case is so special that we really can't use any tools out there. Again, there might be very good reasons why you actually have to do it, but in most cases, that's a bad thing to do. Because if you build your own tools, it brings maintenance with them, bugs fixing everything, and usually you will not have time for it. And again, probably it's not your core business. So if you see flaws and mistakes in the current tools and you think that you can make them better and that they're lacking some features, please add them there so we can all benefit. Again, think about the new guy who's coming to your company. If it's like a tool which everybody uses, he can start the first day. If it's your internal tools, he will spend a lot of time learning them. We didn't talk about basically the endpoints and how we actually tell to our end users which endpoints they should consume, what are the parameters, and what the response is going to look like. And from my experience, it's done in all ways. Mails, chats, basically talking to the people, and they're all bad. You should use the spec. You should use some specification. And specification should be in the lead. So whenever there is some change, first make change in the specification, send it to everybody. Everybody needs to be aware of the change. Everybody agrees on the change. Then you do the coding. One of the specifications that you can use for this is an Open API specification. It is very good specification. There are a lot of heavyweight companies inside its corner. There are a lot of tools available. It's very rich. It has very rich ecosystem. And from my personal experience, it's one of the best at the moment out there. The reason why it's so good and why there's a lot of companies and basically the tools is because it builds on top of Swagger. Swagger basically donated version 2 to the OpenAPI spec, and OpenAPI spec version 3 is basically what Swagger 3 would kind of be. So they, again, like Swagger is battle tested. We spent a lot of time in trenches, so it's really there. We know exactly what it can do and what it can't do. And OpenAPI spec is basically trying to make better specification built on top of all the knowledge from the Swagger. Another very good API specification is RAML, again as an OpenAPI specification. There's a lot of heavyweights in its corner, there are a lot of tools in its very rich ecosystem. Again, RAML came out as an idea to create a better specification compared to what Swagger was at that point of time. OpenAPI spec and RAML both have one very serious flaw, and that is they are both basically created on top of JSON specification, which is a draft. So because of that, they didn't really implement all the features of a JSON specification, because again, JSON specification is changing all the time. And for some things, they basically added some of their own specific flavor. But the good thing is that in most cases, you as an end user will not see this. And the last specification tool that you should check is API Blueprint. It doesn't have very heavyweight companies in its corner like OpenAPI spec and RAML does. It doesn't have that rich ecosystem and tools, but it's tried to be like a cool kid on the block, you know. So it's worth checking out. Another common mistake that people do when they actually develop some APIs is that they don't use any specification, you know, or no standards. And if you don't use any standards, then it means this. Again, long meetings. People will talk about every single thing because there are no standards, so everything is open for discussion. My advice to you is, if you want to avoid this, choose some standard. Any standard is better than having a no standard, because if you have no standard, you will end up in this. Long and long non-productive meetings, you know. And a very good thing about the standard is, if somebody starts saying something, you can always use the standard card and say, okay, sorry, but this is not according to the standard. Especially if that person is not technical and you don't want to do it. I would suggest using something like HateOS, which basically is building on the idea of explorable systems. So if you think about the website, you as a user, when you visit the website, you don't know what all the things are out there, but there are links that you can follow to the new content. And basically, HateOS is additional constraint on top of REST. You can think it in that way. So it's like a REST with additional constraints. One that I would use for using an API is HAL. And no, it's not HAL from 2001 Space Odyssey. It's Hypertext Application Language, if you like long names. And basically, the idea is that HAL brings HateOS capabilities into the API. So the content is self-explanatory, it's explorable, and you can basically do a lot of cool stuff with it. And again, the good thing about any standard when you choose, like for example HAL standard, there are a lot of tools out there going to help you building documentation, writing the code, creating a mockups, whatever you think of, there are tools out there. That's why you should use standard. Word of warning again, HAL is still a draft. So it still means that if you choose some library or some tool, it might not have all the features that you actually want from the HAL, and also it can maybe add some own specific flavor to it. In my case, basically, we had a very specific use case for it, so we hit some edge cases, and in our case, HAL wasn't good enough, so what we did, we said, okay, we are using HAL with these additional constraints. But again, in most cases, you will not hit those edge cases, so even with a plain HAL, you will be perfect. And again, if you hit edge cases, just add more additional constraints like we did. Another common mistake is compatibility, you know. I'm building something now, I know it's cool and everything, okay, I see a problem there, I know how I can make it better, so I'm going to make a new version and I'm going to completely destroy whatever I did before. Don't do this. If you created an endpoint, if you expose that endpoint to end users, that means somebody is consuming that endpoint. Somebody invested time and energy and love into basically getting data from you. And if you take that away from them, it's going to really hurt. And then again, like, why would they ever use your API ever again? So try and make sure that you're always backward compatible. Again, making that forever is very difficult, so probably you're going to have a breaking change at some point in time, but in that case, communicate to your consumers, give them enough time to move to the new version, tell them, okay, this is how you need to, what you need to do in order to move to the new version. I'm not sure about you, but I didn't really work on a lot of APIs, basically as a consumer, where documentation was any good. In most cases, documentation was crap. So please don't make this mistake. Your documentation, like your specifications, should be very sacred to you, and you should make sure that it's always up to date and it's always good. Again, if we talk about somebody coming new, the first thing that he's going to look at about consuming your API is your documentation. If your documentation is bad, what impression you're going to give to him? Again, if you have to move from one version to another version, and it's going to be breaking change, then we're going to look for documentation. Good thing is, if you use OpenAPI Spec, if you use RAML or any other tools, there are a lot of things there that are going to help you create basically great documentation for almost for free. So use it, make a good documentation. Another war story. I have 5 minutes. Ooh, it's going to be tough. So I was working on part of the system that was responsible for all things regarding the money. Any type of transaction, anything that had anything to do with the money that was happening inside the company was touched by this code basically in one way or another, And the problem here was basically that this code wasn't really the best. We can even I would say it was like a huge mess. And the problem, because it was a huge mess, is it wasn't really isolated. It was part of semi-monolith. So I had my code, which was actually doing the finance part, which was a big mess, but it was the part of even the bigger mess where everybody was touching and doing their own stuff. And again, when you have such a big mess, people need some functionality, they need to do something. They're, of course, going to change some parts of the code. And at one point of time, they're going to also touch the finance part and change things there. And that's not good if they don't understand all the business logic and all the business rules. So over and over again, basically we were fixing things that other teams was basically responsible for because they didn't know about the business logic. Only my team knew about it. And one way that I could deal with it is basically being the policeman and watch all the files and all commits, and I would go nuts very soon. So I said, okay, I don't want to do this. I want to basically take my spaghetti code and fix it in a normal way. And the best way that I saw that I can actually fix it and protect it from anybody else touching it is to split it out, right? I just want to take my ball, basically to have one ball where it's my mess and then other ball where everybody else's mess is. So in that way, whoever does things here, he will not touch my ball. And again, if they want something from me, they can just call me over the network and then I will provide them. And I will tell them, okay, you can call these endpoints and I'm going to give you this data back. Again, because this was really huge ball of mass, and like I said, this was really big, very important part of the system, I couldn't just take the code, take it out, and hope for the best. That wasn't a possibility. So what I needed to do is basically, like I said, I needed to create a library, right? I need to identify my blue box and start gathering all the things that I wanted basically inside it. Think, okay, what are the public points that needs to be available to everybody else? Make it as a public points, and hide all other complexity from the end users. Basically, I was drawing a line in the sand like a border, and nobody should pass it, But just building it isn't enough. What's the point of building something if nobody knows about it? So I also had to do a legwork. I went through the company, I was talking to all kind of developers and the teams, and whenever I saw somebody touch anything in the finance, I would go to them and say, you know what, I saw you did this, but we have this new way that we want to actually do. We are creating a very nice library for all the finance stuff. And again, you don't care about the finance, you want to do your work, right? So tell my team what you actually need, we will build for you. If there is no endpoint in this library that helps you, we will create a new one only for you. This way, we will maintain it, we will make sure that we don't break any business rules, and again, you will be able to do your job without any problems, It's basically a win-win situation for everyone. And of course, once I basically were very satisfied with the way that my library looked, nobody was touching anything inside the library, we did the split, right? Library just became standalone application. All public endpoints basically became publicly accessible endpoints became API endpoints, and it was all done, right? All perfect. Again, this wasn't really a trivial task. It took us a lot of time and a lot of work to basically do this because of the whole mess and everything. We had to be extra careful whenever we did this and make sure that we don't break anything, you know. Again, in order to succeed, you need to basically to market yourself, you know, like you need to marketing. Like there is no point of building something great if nobody knows about it or nobody wants to use about it, you know. There is no business like show business, you know. You need to be able to sell your API and your ideas inside the company and outside the company, you know. There are going to be people who are going to say, yeah, but this old way already works, like, so why should I care? Why should I like fix it if it's not broken, you know? Be prepared for those questions, you know, have the answer to those questions before you go to meet them, especially if you know that somebody is going to be a tough nut to crack, you know. Also, you need to be prepared to basically help your end users along the way, to actually lead them into the right direction, to actually show them the light in the end of the tunnel and hope that it's not a train there, right? And not only that you need to help them get on the way, you also need to help them with every step of the way, because they can jump on the road and basically they can just go out of it. This never happened before. Okay, because they can jump on the road and they can also jump out of the road. So help them along the way, especially if the road is going to be a bumpy one. Thank you. Woo. Okay, so I was very fast.
Thank you. We didn't have any question from the bot, but I can ask you one question. Like, sorry, but you have to repeat it. Okay, so what happens when? What happens if you have like multiple services in one like kind of business transaction? So something fails, right? So then you need to roll back everything, right? So what are your experience with that? Like, how harder is it now with microservice architecture to do that?
Okay, so the question is, we have multiple systems and we have transactions over multiple systems, right? And something breaks, so we have to do the rollback. Again, it's always a tough question, it's always a problem. In microservices or no microservices, in microservices it's even more trickier. So basically, what we did is you have to know what your source of the truth is. So, again, depends from the use case. You can either select, okay, in this use case, I don't care if I have some problems and some part of the system is going to break. I will have some script basically running in the background where actually I'm going to just clean up all those stuff. And in most cases, that can work. Like, because again, like if you don't really need something in real time, you can then say, okay, this broke, I'll just mark it as broken, and then I'll have some scheduler which is going to go and clean up my data. If you need to do it in real time, again, you need to know who is owning that application. And usually one microservice is going to basically be the owner of everything, and he will be able to basically to send requests to other multiple microservices and basically like wait for all of them to send back to me, okay, it's confirmed, and then basically say, okay, all is good or not. So again, you need to build that logic in your code itself, because that's the bigger problem with the microservices, because usually every microservice has its own database, so you can't rely on a database for doing that job for yourself. So you basically need to code for it, and that's very, very difficult part always.
Thank you. And another question is, what about performances of the system that you, for example, would you able to compare the old system, the new system that is monolith, and now you're going to the microservices, and then you have more communication, like more network communication between the components. So do you feel any kind of penalty there?
Yeah. Okay. Okay. So the question was. Okay, like in the monolith, like we said, we have function calls and method calls. Everything is internal. Everything is very fast. When we go with the microservices, there is all network calls, right? And like I said, network calls add latency and add delays. So again, depending from your business logic, it really depends. Like if you had basically your monolith, and what you wanted to do was somewhere inside the monolith, and then you took that monolith outside and just exposed it to the whole world, then you gain performance, of course. But if you call from one monolith to another monolith to another monolith to another monolith, of course you're losing performance. That's definitely because there's latency. You're losing there. There is no winning. There is no way to win it unless basically creating some better or clever rules. Again, think very hard when you split things. Do I really need to split it, or should I keep it as one? And what else I want to talk? I forgot. I want to say something else. No. Okay. Oh yeah, I forgot. I remember. Yeah, I remember now. The only thing that you can basically win with the microservices is more availability, because what happens, for example, we had one system which had multiple things, so it was having like. It was like two applications in one. So if we wanted to scale one, we had to scale whole one big application, and that one big application was very slow because it needed to do a lot of other stuff. And when basically we took the microservice out and just created as a standalone application, we basically removed a lot of overhead because it was only dealing what it needs to do. So in that case, we basically gain the functionality and gain the speed. But again, it really depends from your use case to the use case. So that's it.